Hey there guys, welcome to the start of my AS Maths Trigonometry exam questions playlist. In this one, we are looking at sine rule, cosine rule and area of a triangle. Now you might be thinking, that's just GCSE stuff. There are twists in these questions to make them a little bit more tricky, so make sure you try them. Download the questions and you also get these 3 pages. Okay then, first up, a triangular prism has cross-section ABC as shown. We're given some lengths and some angles. We're told the length of the prism is 300 millimeters. Our job is to work out the volume. So, volume is the area of the cross-section times the length. So, we need to work out the area of ABC. Now, the first thing we can do is fill in the third angle at the top. So that's going to be 125. Okay, now to be able to work out the area, we need an angle and 2 sides coming out of that angle. Now we can find another side here using the sine rule. So I'm going to find that side of that. So I'm calling it x. Now, using the sine rule, we know that x over sine 25 is equal to 40 over sine 125. So, from that, we can get x is 40 sine 25 over sine 125. Now the question wants our final answer to 3 sig figs. So anywhere before that, I would always go one step further. So 4 sig figs. So we get then that x is 20.64 millimeters. Okay. So now that we have x, we can now find the area of the triangle. So the area is 1/2 times 20.64 times 40 times sine of 30. Now that gives us 206.4 millimeters squared. We can get the volume, which is 300 millimeters times the area, 206.4. millimeters squared. Now to 3 sig figs. That gives us 61,900. Millimeters cubed. Given number 2, a parallelogram has sides of length 6 centimeters and 4.5 centimeters. The larger interior angles have size alpha. Given that the area of the parallelogram is 24 centimeters squared, find the exact value of tan of alpha. Okay, so the way that trigonometry gets involved here is if we split the parallelogram in half. Like that. So we split it into 2 triangles. Now, we can find an expression for the area of this triangle in terms of alpha, and we also know that it is 12. So, using area of a triangle, we can say that 1/2 times 6 times 4.5 times sine of alpha we know that that is equal to 12 because it's half the parallelogram. Now then, if we multiply through by 2, then we get 6 times 4.5, which is 27. So 27 sine alpha is 24. Now if we divide through by 27, we get sine alpha is 8/9. Okay, so we know the exact value of sine alpha. How do we get tan alpha? Oh, now we think of SOHCAHTOA. So we know that sine of an angle is the opposite over the hypotenuse. So that means in a right-angled triangle, with an angle alpha, we know the opposite would be 8, and the hypotenuse 9. Now, tan of alpha is the opposite over the adjacent, so we need to find the third length. So, for that, we're going to use Pythagoras. So, 9 squared minus 8 squared gives us 17. So, this third length is root 17. So then finally, tan of alpha is 8 over root 17. Okay, then number 3. So this time we have a triangular lawn and we want to find its area to 3 sig figs. So the first thing I would do is fill in the missing angle. So that is 50 degrees. Now we can use the sine rule to find one of the missing sides, and then we can use area. So I'm going to find this side, so I'm going to call it x. So I can say x over sine 60 is equal to 30 over sine 50. Now multiply through by sine 60, and we will get x is 33.92 meters squared. So again the question wants the answer to 3 sig figs, so any workings before go one step further. So now we can find the area. So that's going to be 1/2 times 33.92 times 30 times sine 70. Now that to 3 sig figs gives us 478 meters squared. Okay, then for part B, we want to explain why our answer is unlikely to be accurate to the nearest square meter. So, looking at the model, it's highly unlikely the angles were exactly 60, 70 and 50 degrees. It's highly unlikely the bottom length was exactly 30 meters. So either of those two. We have rounded during our workings out. So we rounded x to 2 decimal places. We could say that. Another thing we could say is that the garden may not be flat, so that would also affect the area. Okay then, number 4. So, in triangle ABC, AB is 10 centimeters, AC is 5, and angle BAC is theta degrees. The area of the triangle is 15 centimeters squared, but find the 2 possible values of cos theta. Alright, so given that we are told what the area is, we can find sine theta. Now the way that we're going to do that is by using the area. So we know that 1/2 times 10 times 5 sine of theta is equal to 15. So 25 sine theta is 15. Divide through by 25 and we get sine theta is 3/5. Okay, now to get cos theta, we actually need to use an identity. So, the one we need is that sine squared and cos squared is equal to 1. So what we're going to do is square both sides, so we get sine squared is 9/25. So that's 1 minus cos squared is 9/25. Now we're going to add cos squared and subtract 9/25 from both sides. So we get 16/25 is equal to cos squared. And then we square root both sides. So finally we get cos theta is plus or minus 4/5. Okay, then for part B, given that BC is the longest side of the triangle, find the exact length of BC. Okay, so this is now a job for the cosine rule. So if we just call the length A, then we know by the cosine rule, A squared is 10 squared add 5 squared, so 125, minus 2 times 10 times 5 cos theta, so that's minus 100 cos theta. Now, we want that to be as big as possible because BC is the longest length. So, we are using cos theta equals minus 4/5. So then the minus becomes plus. So minus 4/5 is minus 0.8. So then we have A squared is 125 plus 80. So A squared is 205. So A is root 205, and that's centimetres. Now they wanted it in exact form, so here that means leave it as a third. And guys, that's this set done. So this playlist is about to get a lot more fun, solving equations using identities, etc. Hope to see you there. Take it easy. Take care.